Hello everyone and welcome to the 8th video in our series on machine learning. I am Kisle Pandey and in today's session we will dive into K-means clustering, a powerful unsupervised learning technique. I will explain the theory, applications and implementation of K-means clustering using R and Python. If you are ready, let's get started. First, let's understand clustering. Clustering is a unsupervised learning methods that group data points based on their similarities. Unlike supervised learning, it doesn't rely on predefined labels. Its applications are vast, including customer segmentation, market research, image compression, and anomaly detection. What is k-means clustering? K-means is a partition-based clustering algorithm that divides data into k groups. Here's how it works. Choose the number of clusters k. Randomly initialize k centroids. Assign each data point in the nearest centroid. Recalculate the centroids as the mean of the assigned points. Repeat until there are no more changes in cluster assignments or centroids. The objective of k-mean is to minimize the within cluster sum of squares over WCSS, which measures the compactness of the clusters. Key parameters in k-means. The main parameters in k-means are number of clusters, k, the number of groups to decide the data into centroids. These are centers of the clusters. Distance metric. The Euclidean distance is commonly used, but other matrices are also applicable. To implement k-means, follow these steps. Load the preprocessed data. Standardize or normalize the features for better performance. Determine the value of k using send methods like the elbow method or Silhouette analysis. Apply the k-means algorithm to assign clusters. Visualize the clusters using scatter plots or other methods to interpret the results. In R, here's a quick demo using the iris dataset. First, we load the dataset and normalize the data. Then we apply k-means clustering with 3 clusters. Finally, we visualize the results using ggplot2. This gives us cluster assignments for each data points along with visual representation of the clusters. Similarly, in Python, we use libraries like csgit, and cbon. After loading the normalizing the data, we apply the k-means class from sckit-learn to find clusters. Then we visualize the clusters using cbon clusters plot. Python's implementation is straightforward and allows flexible customizations. One of the challenges in k-means is selecting the number of clusters. The elbow method. This involves plotting the WSS for different values of k and identifying the points where the curve bends. Silhouette analysis. This measures how well a point fits in its clusters compared to others. Both methods provide insights to determine the most suitable value of k. Finally, let's discuss the pros and cons of k-means. Advantages. It's simple, easy to implement, and scalable for large datasets.